Going to talk a little bit more about the hardware, leading into a demonstration of an actual project that we've been running for the last year. Where we did load management, we were approached by a partner of ours who's in the solar and energy business and asked us to come and look and help them architect something for a spa, a super spa, grocery store. Before I carry on, would anybody like to hesitate what a super spa's energy bill is a month? Let's have a guess. Not millions. £500,000, that's a good guess. Anything between 4 and 550,000 rand a month. It's a lot of energy. And if the challenge in those sorts of industries is they're not energy people. In fact, the manager came, the first meeting I had, it says, we know how to sell baked beans. Okay, we don't know anything about energy. And traditionally with energy was never really a big factor. But it's the one thing they have no control of. You can always negotiate rents with the landlord. You can always negotiate better prices from suppliers. But energy just keeps going up and up and up. It's the one place municipalities are making money and can make money. So that is just something that they're under enormous pressure from. So now they're having to look at what that actually costs them. So we architected again, using our technology with the Droid in the cloud. We talked to 3 lots of other web providers. The first one is AccuEnergy. It's a Canadian-based energy monitoring system. You put a unit down, you can talk to with CTs, up to 6 3-phase or 18 single-phase stations. That gets put into the cloud. We worked with local partners Informed Decisions, Frank and Peter, on these modules that you can see here, and I'll demonstrate that now, but these are fantastic architecture, and that what you do is you put down a master. The master is talking out GPRS to the cloud, and then you put their nodes, what we call our nodes, down. And nodes are typically those little boxes there that you can get up to 4 sensors on per node, and you can create different combinations. So I think we had 3 or 4 different types. 6 different types for the spa, where the one, for example, they wanted one temperature, they wanted a door sensor to see if the door was open, and then they wanted an output to switch a siren on. So if the guys left the freezer door open for too long, they wanted to be able to draw attention because now you're throwing money. Every time cold's coming out of a freezer, you're throwing money away. And then obviously have a temperature sensor. So we have and you can so some are just 4 relays, some are just 4 temperatures. So the nice thing about Frank and them is that you could literally specify those nodes as part of your solution. They're battery backed up, so you always get, even if the power goes down, you get your data, and it returns those values, and it's bidirectional, and it's LoRa, and it's secure. So you can, because it's a LoRa-based comms between the master, the ID-Link master, and the nodes, you can literally put them anywhere in the factory. We've tested these things up to 2 kilometers line of sight. From there to there, 2 kilometers, and it works 100% of the time. In fact, Peter has told me you can do more, but we've tested up to 2K. So running around 200 meters in a store where you've got fridges and concrete and second floor, no issue whatsoever. It's been very successful. So the nice thing about that is that there's no cabling. That node you literally you need a 220 volt supply, and you can wire it in close to source. So you can put these things close to where you need to do the control. And often that's a real challenge in brownfield sites where you want to interact with a building, for example, where they've got distribution boards all over the place and they want to be able to monitor that energy or do that control. Quite a challenge. And then we worked with a Chinese supplier called Moko, who do a smart plug. So, at all the outlets of all these spas, you've got the Red Bull fridge, you've got the Coke fridge. As you walk down the aisle, you want to take one of those guys. Those sit at like, again, 1 kilowatt. When you think of energy, you think 1 kilowatt, but that's running 24 hours a day. And there are 25 of them. So it's 25 kilowatts all the time. And you don't need those necessarily all the time. So we integrated to the back end of Moco that we could then allow them to switch those on and off as and when they want to in the schedule. And then, so we've got the Accu Energy, which is reading energy. I think it comes in every 1 minute.
Accu Energy, you can scale it to whatever you want, but currently we've got it every 30 seconds.
Okay, so every 30 seconds we're getting a real-time feed of what's happening in the plant, okay, in the spa. We are then bringing the data from the sensors and making decisions about control in the SCADA system in the cloud and pushing it out through the Informed Decisions LoRa network and doing the control. And that was quite a challenge. Again, we come from the industrial world where we have got PLCs and we know the reliability that's required. We were suddenly faced with these 3 systems and saying, not feeling comfortable. The first time I met Peter, I said, Peter, I want a Modbus interface on this thing because I want to put a PLC here. So if the cloud fails, I can at least do the control locally. We're getting there. Look at Frank, he's about to fall over here. But we're getting there. So I think there's a big requirement for doing local control, where you literally are just using this as remote I/O and reading and writing based on decisions made in the PLC. But we did extensive tests around that, where we used the SCADA system to switch a relay on. We wired that relay back to another device, relayed that input back via their system to the SCADA, and we just kept looping that. And we did hundreds and thousands of tests, and we worked very hard with Frank to get the sort of feedback that we needed. And again, when you go into control, you know that you need that feedback to understand that what you've said you've done is actually what you've done. And Frank and Peter and their team have worked really hard with us to ensure that we get those sort of feedback that we can reliably know. To give you some idea, some of those meat fridges you see at Checkers and at Spa hold 40,000 rands worth of stock. If the temperature in that fridge goes above 24 degrees, they throw the entire stock away. They're obliged in law to throw it away. So you can't just say, well, I'm switching off the fridge, and you think the fridge is back on, and next thing you get a phone call to say, here's an invoice for 40,000 rand. So we worked really hard at that, and I must admit, we are very comfortable actually doing this control over the internet. Then we've integrated the smart plugs and, of course, Adroit Air. You saw Raymond show that. That shows the manager. And these guys didn't want infrastructure in the spa. They know nothing about automation. They know nothing about the technical aspects of power. So again, put it in the cloud, doing analytics, etc. We're going to go straight into the demo. This is just and again, we use our secure mobile gateway so the guys can literally log on with their phones at home and see what's happening. And a lot of the stuff we put in was temperature, being able to do defrost cycles, because again, that's kilowatts, scheduling defrost cycles out of time of use. And again, this is where we learned a lot about costs of energy and municipal costs of energy. To give you some idea, whoever knows about time of use, but there are tariff structures that are markedly different based on the use of time, of energy and time. So for example, from 6 o'clock in the morning, I think the current system is 6 until 9. That's peak energy, because obviously they have to feed domestic people waking up, not industrial users. And I think between 6 and 8 at night, typically.
7 to 9 in the morning.
Okay, so 7 to 9 in the morning currently, but that does change in winter. The energy in that period of time is 5 times the cost of off-peak. They're paying 5 rand a kilowatt hour compared to 98 cents. So if you're not looking at processes these days in terms of time of use of energy, you are wasting enormous amounts of money. And we're even seeing this with industrial users now. If you have to be looking at time of use, etc. Right, so before we get into here, I wanted to demo quickly this unit here. And in order to do that, I've actually got it. This is live data coming from Spark. This gives the guy a look at the floor. You can see all the instruments that we've got in there. Can you hear me clear? So, okay. So what this gives us here, you can see where they can switch fridges on and off using the smart plugs. We've also, these are the smart plugs here. You can click on one. So the guy can click on here, he can go to the scheduler. We give them obviously the status because we like to know that we are working. And here the manager can go in and say, switch this thing off between 1 o'clock, or in fact, from 7 o'clock until 6 o'clock in the morning. So that's what they can set up for those things. A very easy interface. Thank you. Close that. And so each of these is a different node that we've got here. You can see the temperature. Right now the temperature here is 7 degrees. It's an alarm. And the spin-off to this was now they can back up. If a customer comes in and says, my meat's gone rotten, they can say, well, when did you buy it? They can go back in time. They can see what the temperature was. They can say, or any regulatory body comes in, they've got a full quality control behind the scenes here in terms of looking at their data. We've integrated temperature and humidity. And why is that important? Because again, the fun thing about projects like this is you start to understand refrigeration and the impact of humidity, temperature on refrigeration and energy, which is big energy. Go to the Dave's device. That there is just a demo device for here. And to show you the sort of speed that we're getting, I'm going to ask John. You can see the temperature in here is 20.99. So this has got a relay contact output or a door switch, so they can see when the door opens. They can count the times it was open, how long it was open for, and obviously alarm that. And then we have a temperature sensor, and we have 2 relay outputs. So that's a node in there. There's the radio. It communicates back to this guy. And I'm going to ask John to switch on the first relay. If you want to just put a timer on that. Now we've instructed it to go and switch on. It's gone from our system over the internet to their system back over GPRS to the master, and communicating radio to here. And that was less than 5 seconds. So you can see, and then you can see that I've opened the door switch. It's opened. And we also have a leak detector. They have a big problem in that they sometimes, if the deep or the defrost cycles go on too long, or there's a fridge failure, of course they get water leaking all over the place. So we've got integrated here a leak detector. You can see it says dry. I've got water here. You'll see it's green. The moment I put it in, it goes red. And a minute later, you'll see that we'll get an alarm. So traditional SCADA system, and this is the difference between us and people who supply you off-the-shelf solutions in the cloud. You can be completely flexible and use the power. It's gone wet. So it's told you that's how quick you now get an alarm on your phone. Hey, there's something wrong. Go and have a look at your fridge. Now you can address it, and there's the alarm up there, which we then put into our alarm management system, which then starts analyzing where the fridges are continuously being a problem. That's the power of using a SCADA instead of an off-the-shelf solution where we can integrate to many systems. And again, Adroit's in the cloud here. Thanks, John. Right, so that's the sort of instrumentation overview if you want to. Let's go to the power. And this is where it gets interesting. So in real time, these guys can see, you can see currently they're using 300 kilowatts in that spa. 300 kilowatts, it's not a It's not a small amount of energy. You can see what is split between the generator supply and what is from the municipality. Then we've gone down to one lower level, which is the big DB boards, where then feeds all the other distribution points. Now, without having this data, you can't even begin to understand where your problems are. So the first key is to get this. And one of the big challenges we found is the multiplex panels, which I'll get to now. The overview gives them a few things. It gives them, we're using our max demand agent. You can see the max demand, the demand going up every half an hour. And we're doing load control with that. So we are saying we've set the max demand limit to 250 kilowatts. The agent itself looks at it and says, right, you're actually going to exceed it. Start switching off. So you can see after 15 minutes, we switch off the one set of loads. A minute later, we said we're still going to exceed it, switch off the next set of loads, etc. We don't have enough control over loads to get them down to that right now. But what we're doing is we're also got built in as part of our max demand agent is that the moment I start doing load control, I lock in what my predicted max demand is, and I can see what I'm going to be saving over a period of time. So we give them a real-time view of what they're actually saving in rands in that period. So that's what the max demand is, and I'll show you the results just now. You can see the relay switching off. And at the end of the period, they come back in. Boom, boom, boom. So that's a very useful way of doing control. Then they can go to the load distribution, which is a real-time view of what's using their energy at any point in time. And then they can go in here and they can say, hey, what's happening here? Oh, the aircon's actually using, or the freezer's using, or whatever. They can actually see where the distribution of their energy is happening in real time. And then, based on the max demand, we have load savings, which gives them a accumulated month-to-date saving of energy. And this is where the idea of using and changing your consumption based on time makes a lot of sense. So you can see here, this is KVA savings month-to-date, and we're on the 10th. On standard time, we've saved them 2,800 kVA. It's quite a big chunk, okay? But in rand terms, we've saved them only 788 rand there for that much energy. If you go to peak, we've saved them 1,100 kVA, but in peak, we've saved them over 6,500 rands with the energy. So the leverage you get of managing your energy in time of use is huge. Huge. So how does that impact us? Let's go to all energy trends, John. So this is a view of all the energy, if you want to. Gives you a 24-hour view. There's a lot of data coming through here. So. And then what we also got our guys to do is, this is the real-time use of their energy. You can see a typical use of this, where at 7 o'clock they close the store, energy drops down, but they're still using about 150 kilowatts. So we're going in and saying, so what's using the energy? And then we're drilling in, and I'll show you some of that stuff. And then, of course, they come in at 5 o'clock in the morning, and they start using it. But we also overlay. Again, this is having one level of context higher, is we can see the time of use. So the guys can look and say, geez, I am cooking on gas here in time of use. So I'm using on average, I think that's probably 250 kilowatts at 5 rand an hour over 3 hours. You know, that's 2.5 grand, that's 2 grand by itself. So you can focus your efforts on shifting energy, on controlling energy better, with this sort of visualization behind the scenes. We're looking at adding this as a sort of standard context on our trends, because it answers so many questions. Can you imagine, for example, if we could have overlaid the product type being batched in the batching? We could have very quickly seen that we're actually making pair. Okay, so we learned that, and we're just trying to figure out how we can do that. So that's very useful. We can close that, John. We know that one of the big problems, and again, this is where we learn, is the multiplexer panel. If you click on the multiplexer panel there. No, okay. Don't worry. The multiplexer is a central compressor system which uses VSDs, and technically what it's supposed to do is switch enough direct online and then control the pressure with the VSD. We found these things are running at 100% all the time. And you can see that's a big user of energy. On average, the multiplex units over the last 24 hours is using 64 kilowatts continuously. So it's not working like it is. When you go to these guys and say, hey, there's a problem here, let's have a look at it, but without this, they've got no chance without looking at this. Now what we're doing is we're getting a bit smarter, and we are looking at overlaying what fridges that feeds, looking at the temperature of those fridges, working out whether this energy loss here is balanced by that. So we're trying to find out where the problem is. And you can only do that by having the data. So all of this data goes to the cloud. And we've got people like Alvin, in fact, who's been modeling also external factors, because you can now, you're in the cloud. We've brought in temperature, external humidity, time of day, and we're trying to model the usage against those factors and see what influence they have in terms of your energy usage. Because 500,000, that's a 6 million rand energy bill. It's a lot of baked beans, profit on baked beans. So again, we've had a tremendous lot of fun with this. It's been a complex, long project that's how we built the IoT agent capability. So we built a lot of our cloud-based technology, and we're starting to see the results of this and been asked to engage a number of other companies. You can close that down, John. The other thing, of course, is that we're looking. Won't close. Okay. Just to give you some idea of where it first hit us, if you just open this, John, just there. You'll see what struck us was, look at the energy of this multiplex. It's supposed to be a smooth curve. There's something wrong here. And that's what led us to start thinking about what the hell is this thing feeding? It's not supposed to work like that. In fact, Steve was in Durban. He went and spent some time looking at the panel. And we're now working with them on trying to understand that. Okay, John. And then lastly, what they can see is they can also see an estimate in dollars. Aiden, in dollars. No, it's in rands. Of what their energy cost is per month. So that's a real-time view of their bill, because we know the tariffs, we know the network charges, we know the time of use, and we can calculate the cost of energy and give them an estimate. And that comes out generally within 5%. So now the manager looks and says, "Ooh, it's getting up there." Okay, John, let's go. Okay, we'll get questions now. Right, to give you the results, so some of the results we're getting so far, and I think this is key, this is the last 2 months, is you will see that this is 5 years worth of data of their monthly consumption and their bills. We've had the lowest kilowatt hours used in 5 years since we initiated the system. Started doing the control, you can see that we've had the lowest energy consumption. Not necessarily the cost, because the cost they just keep putting up of kilowatt hours. We are looking at trying to minimize that. If you left it, they would be up here somewhere. Okay. And then, of course, the max demand, we are looking at lowering the max demand. It's gone a little bit higher there. But again, it's an ongoing process that we engage the customer in terms of being able to do this.